So we're doing 8.5 linear, exponential, and quadratic models. So we are going to determine if functions are linear, exponential, or quadratic. So linear functions are going to be that the first difference, so finding that difference between x and y, will be the same. Exponential, the ratios of consecutive y values are the same. And quadratic, the second difference is going to be constant. So we have to take some information and decide which one is it. Since we've done all three, we can look at them and find that out. So we have this table, and we are going to determine if it is linear, exponential, or quadratic. The first thing we're going to do is find the difference in the y and the x value. So just like if we were trying to find slope, right? So we would go from here to here, right? 1 minus -1 would get us 2. Actually, I'm going to do this. I want room on the other side. Whoa. Don't even know what I just did. Sorry about that. I'm going to scoot this over. All right, there we go. So we're finding the difference. So 1 take away -1, we would get 2. Same thing here, 3 take away 1 gets me 2. This is also 2, and this is also 2. And then we technically check here, right? These are -1 minus -2 gets me 1, and from here to here gets me 1, and they get me 1. So since this is the same every single time, and technically, right, we would find that slope and say it's constant, it's 2 every single time, then we would consider this to be a linear function, because this rate that's moving x and y are the same every time. 2, 2, 2, 2, 2 compared to 1, 1, 1, 1, 1. Okay, so this is linear because it is constant. So here is my next one. Again, I'm going to scoot this over so that I have room on both sides. So we do the same thing, right? 9 take away 3 gets me 6. But 19 take away 9 would get me 10. And then I do 33 take away 19, and that would get me 14. And then 51 take away 33 would get me 18. So we already know that this is not constant, because also this is all 1, right? So we know it's not going to be constant. These are supposed to be arrows, because these move by 1, and these all move by different amounts, 6, 10, 14, 18. So what we do is we then check this next difference, and I'm going to do it in another color. We check from here to here. So I do 10 take away 6, and I get 4. And then I go 14 take away 10, and I get 4. And 18 take away 14, and I get 4. So since our second difference of our y's is constant, this secondary, right? This is our second difference. Since this is constant, this is going to be a quadratic. So when the second difference is constant, then we know it's going to be a quadratic. Okay, so first difference isn't, but second difference is. This is my day today. So we have our third example. Again, I'm going to slide it over. So we check our first difference. 2 take away 1 is 1. Second difference, 4 take away 2 is 2. Third difference, 8 take away 4 is 4. That's a horrible 4. And sorry, not second difference. These were still my first difference, but 16 take away 8 is 8. These all move by 1. But again, my first difference is not constant, so I'm going to check my second difference. So I'm going to go like this. 2 take away 1 is 1. And 4 take away 2 is 2. And 8 take away 4 is 4. So now my second difference is still not constant. So this is not going to be a quadratic. So it's not linear because of this. It's not a quadratic because of this. And so for the last thing we would do is technically check the ratios of these differences to see. So we would then check the ratios instead of our y values. So now I'm going to change this actually to a third color. Okay, so our first difference didn't work. Hold on, color coding. Okay, so our first difference didn't work. Our second difference didn't work. So now we're going to check the ratio of our y's, or y values. So I'm going to take 2 over 1 and I get 2, right? I took 2 over 1. And then I'm going to take 4 compared to 2 and I get 2. That's this right here. So I'm just writing the ratios this way. So I'm going to do 8 over 4 and I get 2. And then I'm going to do 16 over 8 and I get 2. Since we have this common, we would then call this an exponential. If this still didn't work, we wouldn't have a name for it, right? Not yet. So first difference the same, linear. Second difference the same, quadratic. Ratios of my y values the same, exponential. Okay, so that's all the 3 ways we can check this. All right, so this would maybe be a good time for you to at least try A and then see how we do. And then you can try B and see how we do and see if you also agree with what I get. All right, I'm gonna do my first difference. I kind of like to go this way because then I think about subtracting, right? Oh my gosh, you guys, my computer is being so stupid today. All right, you work. Obviously, I need to deal with my computer. As I was saying, I like to subtract this way so that I know that I'm subtracting. But it doesn't really matter. The difference is going to be the same. It's either constant or it isn't, right? So negative 50 minus, don't mind that, 29 negative. This is negative 21. And then I do 29 negative minus 14 negative. I get negative 15. 14 negative minus 5 negative is negative 9. And 5 negative minus 2 negative would get me negative 3. So obviously my first difference doesn't work, so I'm going to then check what we call our second difference. So 21 negative minus 15 negative. This gets me negative 6. 15 negative minus 9 negative gets me negative 6. And from these two, it is also negative 6. So since these are all the same, this is a quadratic. Alrighty. So we're going to do the same thing here. Oh, let me color code. I'm going to stick with my first difference as with blue. So 324 minus 108, 216. 108 minus 36. Hopefully you did this before I did. 72. 36 minus 12 is 24. And 12 minus 4 is 8. So obviously my first difference did not work, so I'm going to check my second difference. 216 minus 72, 144. 72 minus 24 is not going to be 144. So we already know our second difference doesn't work, but just so we write it out. So then the last thing we have to check is these ratios. So 324 over 108. This gives me perfectly 3. 108 compared to 36 also gets me 3. 36 over 12 gets me 3. And 12 over 4 gets me 3. So this is exponential because this ratio worked. Oh, let me just double check. Did I really finish? Oh, good. All right. Yay for my slow computer. So, sorry, I'm just double checking. I don't want to miss anything. All right, so the main things to remember, our first difference constant will be linear. Our second difference constant will be quadratic. And our third difference, or not our third difference, our ratio of our y being constant will be exponential. And I know I just said it all, but I'm going to type it all right here in a second. Make this a little different. So, first difference constant equals linear, and I know I spelled that wrong. Second difference constant equals quadratic, and then ratio of y values constant. You guys, I forgot an S in this one. Equals exponential. Okay. So those are the three things you are checking. I just made it a little bit smaller so it fit in there better. There we go. You guys, I can't spell today. You know how to spell this. Anyway, here your independent practice. You are, again, just doing exactly what the video said. Okay, so check your first difference, second difference, and then your ratios. All right, until next time, adios.